Hello students, so welcome to my video again. So in the previous video we just finished the algebra portions. Now we'll be starting the what we call geometry. Okay, the geometry portions. So in the geometry portions, first we'll be starting unit 11. Okay, so unit 11, that is the area of triangles and quadrilaterals. Okay, how the area of triangles and coordinators, they are interrelated in certain conditions, in certain circumstances. Okay, so there are some, certain corollary that we'll be needing in order to solve the problems relevant to this exercise. Okay, so these are the three theorems that you have to prove in this chapter. By theoretical methods. So I have taken here some of the theoretical, the corollary here. Yes. Okay. So the first one, the first theorem, corollary and theorem means the same. Okay. Do not, do not get obligated into that, sentence. Okay. Okay. This number one. Parallelogram on the same base and between the same parallel lines are equal. So what is meant by that? So first we are going to prove that prove this statement theoretically. Okay. So for that first I'll try to explain what is meant by this. So parallelogram on the same base and between the same parallel lines are equal, which means suppose there are two parallel lines. Okay. So and there is one base AB. So in AB there is standing one parallelogram here, ABCD, and on the same base, okay, and on the same base, if there is also another parallelogram, consider that parallelogram. Consider that parallelogram AB, EF. So now here there are two parallelograms here. You can see, okay. One parallelogram is ABCD, ABCD, and another parallelogram is which is standing on the same base AB, that is ABFE, ABFE. So there are two parallelograms. One is ABCD and another is ABFE, ABFE, and both parallelograms are standing on the same base AB, okay, and under the same parallel lines DC. You can call it the parallel lines. Let's consider this PQ, okay, and this RS. So you can see here. So this parallelogram ABCD and another parallelogram ABFE, they are standing on the both on the same base AB and between the same parallel lines PQ and RS. So in this case what happened is area of this parallelogram, okay, ABCD will be equals to the area of parallelogram ABFE. So the condition that has to be is the both parallelogram has to be on the same base and between the same parallel lines. So if the area of parallelogram, this parallelogram is for example 20 meters square, then the area of the this ABFE, this parallelogram will also be 20 meters square. Okay, if the area of ABCD is if the area of parallelogram ABCD is 20 meters square, and the area of ABFE is also then 20 meters square, because they are standing on the same base and between the same parallel lines. Okay, they are standing on the same base AB and under the same parallel lines and between the same parallel lines PQ and RS. So such type of questions will be given in the problems related to this. Okay, so we are going to prove this theoretically. So it will be in I think in 3 marks questions. So okay, so let's go into this. Okay, let's move into the theoretical part of this. So how to prove this, the parallelogram on the same base and between the same parallel lines are equal. Okay, so in this case you just need to make a diagram here. Okay, just make a diagram here. So yes, just make a diagram. So yes, this look like trapezium. Okay, and make your parallel. Okay, this and this lines must be parallel, and then after, okay, just make one parallelogram here, one parallelogram here. Okay, this let's say this A B C D. This parallelogram is A B C D, and another parallelogram on the same base. On the same base, AB standing on the same base. Okay, let's get this here. Okay, now I'm going to just remove this. Okay, so yes, I'm going to prove this with the method easiest way possible. So using the area of parallelogram. Okay, so okay, now this is good. Okay, now look here, you can see now ABCD is one parallelogram, and on the same base draw another parallelogram. ABCD is already here, so ABCD, let's say this AB, this EF. Okay, so here are two parallelograms ABCD and another parallelogram ABEF. So here are two parallelograms standing on same base AB and under the same parallel lines DE and AB. So in this case, so I'm going to prove this theoretically by the easiest way possible. Okay, so in this case I'll be using the formula area of parallelogram. So what will be the area formula for the area of parallelogram? That is area of parallelogram. The area of parallelogram is given by base into height, and height must be perpendicular. Okay, the height which is taken must be perfectly perpendicular to the base. So in this case we'll be constructing the height for the both both parallelogram. So first of all, this in this case, first of all, just for this, in order to prove this, you have to write given. The construction of figure is already done here. Then after, you just have to write here given. So what is given here? DE parallel to AB, and another parallelogram ABCD and parallelogram another parallelogram ABEF. ABEF are standing on same base. Okay, standing on same base and under. Okay, you can write up to here because we have already mentioned DE parallel AB. So in this case, now what you have to prove is you have to prove area of parallelogram ABCD is equals to area of parallelogram ABEF. Okay, now you have to do slight construction there. The construction that you have to do is draw perpendicular line. Let's suppose that line okay, let's suppose that line xy. Okay, this is x and this is y. Okay, draw perpendicular line xy between the parallel parallel lines. Okay, so we have done the we have drawn the figure, then after we have written the given. Okay, the given, after the given we have also written the to prove, and then after construction that we have done in order to prove this, the parallel on the same base and between the same parallel lines are equal. In order to prove that, I have I have written here, I have constructed here xy perpendicular, the xy perpendicular height between these parallel lines. Okay, now after that you will be needing statement and reason. Statement and reasons. So it will be very quick and short. Okay, so now let's move on to the number one. Let's move on to number one. So this area of, what will be the area of parallelogram ABCD? First we take parallelogram ABCD. That will be base. The area of parallelogram is given by, we'll be using this formula, okay? The area of parallelogram will be given by base into height. So for this parallelogram ABCD, for this parallelogram only, I'll try to hide the remaining parallelogram, so you might not be more confused in this. Okay, now we can only see ABCD parallelogram. Okay, in this case the area of the parallelogram will be given by base, which is AB, and the perpendicular height is xy, which we have drawn. Okay, the base. So area of parallelogram, the formula for the area of parallelogram is base into height, and the base is here AB and the height is xy. So I'll be writing here, base is AB multiply and the height is xy. AB multiply xy. Okay, so the reason will be here. For this reason, the reason will be this: area of parallelogram is base into height. Area of parallelogram will be base into height. Okay, now in the same way, let's go for this this parallelogram ABEF. So for parallelogram ABEF, the base is AB and the height will be the same, xy. Okay, the height will be the same for both parallelogram, that is xy. So in number 2 you write here, now area of parallelogram ABEF. So in parallelogram ABEF also, the base is AB and the height is xy, perpendicular height xy. Okay, so the reason will be here the same, area of parallelogram equals to base into height. Okay. So now in number 3, since area of parallelogram is also equals to area of parallelogram ABCD is also equals to AB into XY, and area of parallelogram ABEF is also AB into XY. Since they are both equal to the same, AB times XY and AB times XY, you can directly write now area of parallelogram ABCD is equals to area of parallelogram ABEF. Okay, so the same AB times XY is equals to area of parallelogram ABCD, and the same AB times XY is also equals to the area of parallelogram ABEF. Because of this, they both have the area of both parallelogram ABCD and the area of both parallelogram ABCD and another parallelogram ABEF is equal. So the reason here 3 will be, the reason of the statement 3 will be from statement 1 and 2. From statement 1 and 2. And now you can write here proved. Yes. Okay. So this is how it is done. So it is the easiest way to prove the parallelogram on the same base and between the same parallel lines are equal. So you just try to only follow this. Okay. Just try to only follow this, not to to waste time on the in more complicated methods. It is the best, sweet and short. Okay. Okay. So if you have finished this, then okay. If you haven't, just take a screenshot. And without further delay, I would like to move into the number 2 theorem. The area of triangle is equals to the half of the area of parallelogram standing on the same base and between the same parallel lines. So for that reason also, I'll be using the same methods. Okay, so let's move on to the number 2. So for the next theorem, okay, now for the next theorem, so I'll be using the same methods, okay, to prove this theorem also. The area of the triangle is equals to the half of the area of parallelogram standing on the same base and on the same parallel lines. So what is meant by that is, so there is 2 parallel lines, PQ and RS. Let's, for the sake of argument, let's say that PQ and RS, those are the 2 parallel lines, and let's there be a base AB. In AB, there is standing one parallelogram ABCD. Okay. So and also on the same base, if there is standing another triangle, okay. So if there is standing another triangle, then this for example, this ABCD is a parallelogram, and on the same base there is standing another parallelogram, another triangle, which is AB. Let's for CD. Let's say this E. Okay. So there are two figures, geometrical figures. One is parallelogram ABCD, and another is triangle ABE. So what this statement is trying to say is, if there is one parallelogram and another triangle, and both are standing on the same base AB, and under the same parallel lines PQ and RS, okay, this triangle and this parallelogram, they are standing on the same base AB, and between the same parallel lines, that is PQ and RS, then in this case, the area of triangle is equals to the half of the area of, now this area of triangle will be half of the area of parallelogram ABCD. So this is what is trying to convey by this statement. So for example, if the value of this parallelogram, the area of this, for example, if the area of this triangle is 20, then this area of parallelogram will be just the double of 20, that will be 40. Okay, for the sake of argument, let's say if the area of this parallelogram is 50, then the area of this triangle will be 25 meter square, square units. Okay, so it just they have to be on the same base and between the same parallel lines in order to establish this relations as proposed by this statement, as been stated by this statement. Okay, so if they are standing on the same base and between the same parallel lines, then the area of triangle will be half of the area of the parallelogram. So we'll try to prove this theoretically. First of all, in the previous theorem also, I used the area of parallelogram. Area of parallelogram, that is base into height. Now in this case I will be using area of parallelogram plus area of triangle, which is 1/2 base into height. Okay, so for that thing I'll be constructing just like in the theorem 1, in the this theorem I have drawn perpendicular height xy. So in this case also I'm going to do same thing like that. Okay, so let's move on to this. Okay, so let's first make the figure. Okay, figure is important, very mandatory. So just take the figure, just draw parallel lines. Okay, opposite parallel lines. Now let's say AB will be the base. Okay, so I'm going to make here a parallelogram. Yes, ABCD. AB, let's name this CD. So these two lines are parallel, and this is also parallel. Now ABCD is here the parallelogram. Now on the same base AB, let's draw another triangle, not the parallelogram, another triangle. Okay, CD, E. ABCD, let's say this E. So now you can see here this parallelogram ABCD and this triangle ABE, they are both standing on the same base AB and under the same parallel lines DE and AB. So after this figure you have to write here given. Given here is what? DE, or you can directly write here parallelogram AB, CD and triangle ABE. ABE are STANDING, standing on same base and under same parallel lines. Parallel lines. Okay. So after this, you have to write to prove. You have to prove is area of triangle ABE must be equals to 1/2 area of parallelogram ABCD. So this you have to prove, and for that to prove this, I'm just going to make here constructions be made in order to prove this statement. That is, draw perpendicular height or draw perpendicular length xy between the parallel lines. Okay, draw perpendicular length xy between the parallel lines. So in that case I'll be making parallel lines there. Okay, so you can make parallel lines here. Just make perpendicular parallel lines here. Okay, you can see. So x, y, and give it a perpendicular sign here. So for both parallelogram ABCD, and for both parallelogram ABCD and triangle AEB, this will represent the height. Okay, this xy will represent the height of this parallelogram as well as for this triangle. So for this, as I already mentioned to you earlier, area of triangle will be given by 1/2 base into height, and area of parallelogram will be given by base into height. So we'll be using this formula in order to prove this. Now here just write a statement and reason. Okay, so let's move into this. So what will be the area of parallelogram? What will be the area of parallelogram ABCD? So in parallelogram ABCD, AB will be the base, AB times, and xy will be the height. And you write the reason. Area of parallelogram is equals to base into height. In the same way, now you can write area of triangle ABE. So in this case, this will be 1/2, base will be AB, and length height will be xy. So in this case you write the reason. Area of triangle is equals to 1/2 base into height. So for triangle ABE also, the base will be AB and the height will be xy. So now from 1 and 2 you can write here. So just write here area of triangle ABE is equals to 1/2, and replace this AB times xy. This AB times xy, okay? This AB times xy. This AB times xy is equals to area of parallelogram ABCD. So replace this AB times xy, AB into xy by area of parallelogram ABCD. Okay, so I have just replaced the value of AB times xy by area of parallelogram ABCD. Now you have to write here reason from statement 1 to n. From statement 1 and 2. From statement 1 and 2. So this which we have to prove. Now it is proved, and this is how it is done. Okay, just follow these simple steps, and it's very easy. Okay, so after this, now we'll be doing another theorem. I think you got the idea how to do that. If you can do by yourself, then you can just start earlier than me. If you don't know how to do this, I'll just do that theorem number 3 also. Okay, we have just finished 1 and 2 just right now. Now that will be the last theorem which I will prove here in this video. So that one is very easy, just like this. You can also use the same methods on proving that number 3. Triangles on the same base and between the same parallel lines are equal in area. It's very easy. Just make two triangles standing on the same base for that number 3, particularly for this number 3. Just make angles, two triangles standing on the same base and between the same parallel lines, and then after just draw perpendicular height, perpendicular length, perpendicular height between the parallel lines, and then after use the area of triangle. So if you know how to do this, you can start it earlier, and then after. Okay, now without any further delay, let's go into the number 3. Okay, number 3, very easy. So if you know how to do that, you can just start it earlier than me. Okay, so let's move on to the number 3 without further delay. So this number 3, triangles on the same base and between the same parallel lines are equal in area. What is meant by that is, if there is two parallel lines and AB be the base, and in this AB there is standing two triangles. First say ABC is one a triangle and another triangle ABC. Let's say this D. So you can see there are two triangles, triangle ABC, and another triangle ABD. So two triangles are standing on the same base AB, and between the same parallel lines AB and BC. So they are standing on the same base AB and between the same parallel lines AB and BC. So in this case, both the area of triangle will be equal. The area of triangle ABD will be equal to area of triangle ABC. So if this is 30 meter square, then this also will be 30 meter square. And the reason that you have to give is triangles standing on the same base and under the same parallel lines, that you have to state that. So you must try to remember this statement. Okay, so while you do exercises, so remembering that statement is very crucial. Okay, let's move into the theoretical improvement. Okay, where I kept my duster. Okay, here is it. Okay, now just draw two parallel lines there. I'm going to make here two parallel lines. Okay. I'll just write here PQ RS. So PQ RS gives two parallel lines, and let's say there is one base AB. Okay, so from AB, I'm making here ABC one triangle. Okay, and on the same base AB, I'm going to make another triangle on point D. Okay. Okay, so you can see here. So there becomes two triangle ABC and ABD standing on the same base. Standing on the same base AB and between the same parallel lines PQ and RS. So for this, for both triangles, I'll make here a perpendicular line between the parallel lines PQ and RS. Let's say that XY. Okay. Okay. So we can draw this XY perpendicular line inside this box. Also, it doesn't matter. It doesn't matter. This XY will represent heights for the both triangle. Okay. So first you write given. In given, you just write triangle ABC and triangle ABD are standing on same base and under same parallel lines. Okay, so the same base. Okay, so you have to prove this. To prove that is area of triangle ABC is equals to area of triangle ABE. Yes? Okay. Now for that you need to construct. What do you have to construct? Draw XY perpendicular to PQ and AS, or you can write draw XY, draw perpendicular, okay, CULAR, perpendicular XY between the lines, between the parallel lines actually, between the parallel lines PQ and RS, PQ and RS. So now after that, you just write here statement and reason. Okay, first one. So in first one, you just write area of triangle. Area of triangle ABC. This area of triangle will be 1 by 2. Here base will be AB and height will be XY. And the reason you give is area of triangle is equals to 1 by 2 base into height. In the same way, in number 2 also, area of triangle ABD is equals to 1 by 2 times. So in triangle ABD also, AB will be the base and the height will be the same, XY. So here also give the reason area of triangle is equals to 1 by 2 base into height. Now, so area of triangle is also equals to, area of triangle ABC is also equals to 1 by 2 AB times XY, and area of triangle ABD is also equals to 1 by 2 AB times XY. So which means from this both, combining this both, you can write area of triangle ABC is equals to area of triangle ABD. So which we have to prove. Now for this statement, you can from statement statement from this statement 1 and 2 proved. Okay, so even if you don't know a lot of theorems, or a lot of out theorems, at least try to know these 3 of these theorems. Okay, if you don't know all the theorems, if you can't get all those theorems into your mind, try to at least remember this 1, 2 and 3 theorems. Very important, and it will be using from time to time, frequently. Okay, that's why it's very important to remember this theorem, to how to prove this theorem theoretically. This 1 and 2 and 3, this you have to know. This is the basics. Okay, so 1, 2 and 3 at least you have to know this. Okay, so the very easy way that I have mentioned here, how to prove this theorem. So these 3, you must need to know how to prove these 3 theorems. And okay, this much for today's video. So I hope you like this video, and I am able to make this a little bit more clear concept about this theorems. So this number 3 was the last theorems for today's video. So with that saying, I'd like to end this video here. If you like my video, if you find my content more valuable, then just try to share to your friend circles, and don't forget to like Don't forget to like, hit subscribe to my channel. So until then, goodbye, see you, and take care.